Hello everyone. Welcome to online survey tutorials on hydrology and irrigation engineering. So today we will continue the problems on evaporation and infiltration. So here is a problem. So you can see here. I'll just read out the problem. For a storm of 3-hour duration, the rainfall rates are as follows. Time period in minutes. They have given the time period as 30 interval, 30 minutes interval, and the rainfall rate in centimeter per hour. So for all the 30 minutes interval, like as it is a 3-hour duration, so for first 30 minutes 1.4, and similarly next 30 minutes it is 3.4 centimeter per hour, and correspondingly like 4.8, 3.22 and 1.2 centimeter per hour are the rainfall for a successive 30-minute interval for a 3 hour. So if the surface runoff is 3.4 centimeter, determine the phi index and W index and assume the initial phi index is more than 1.4 centimeter per hour. Okay, so this problem was asked in December 2018 and Jan 19 for a 8 marks. Okay, so let us just write on the given data. Like they have given the depth of runoff, that is denoted as Q as 3.4 centimeter, and you have to calculate phi index and W index. So for that, so the formula which you have to remember, as you know, the general water budget equation also, that is runoff is equal to rainfall minus losses. So here the rainfall is denoted as I, and the losses are your phi index. Okay, so phi index are the losses. So let us just proceed how we are going to calculate the phi index. So if you see here, so first is phi index. So I represents the rainfall rate, that is in centimeter per hour, as I have told, and the phi index is also expressed in centimeter per hour. Okay, so the formula which we are going to use is runoff is equal to summation of I minus phi, because we have a 3-hour storm duration. So 3-hour rainfall is there. So I minus, that is summation of I minus phi into T. So where T is in terms of hours, but I know the time period here it is given in terms of minutes. So you have to convert into hours. So initial phi index should be not more than 1.4 centimeter. So that they have mentioned in the problem itself. So the initial phi index value should not be more than 1.4 centimeter per hour. Okay. So if you see here, so the rainfall data which is given. So the initial rainfall is 1.4. So phi index should not, as they have given, it should be more than 1.4. Okay. So it should be more than 1.4 means. So whatever this 1.4 centimeter of rainfall which falls on the ground, so that will be as in losses. Okay, so that you should consider. So in calculation here, so in the calculation you have to consider. So while considering the I value, that is the intensity of rainfall, you have to consider more than 1.4 centimeter values. Okay, so that is, if you see here in the tabular column, so this first first reading will get so you're not going to consider this first reading because it is 1.4, but we have to consider only the I which is more than 1.4 centimeter per hour, and similarly the last reading. So you should not consider the first and the last reading. So while in the formula, while you're substituting here, while you're calculating, so the runoff they have given as 3.4 centimeter is equal to, so leaving that the intensity of rainfall that is more than 1.4 centimeter. See, as I have told, why we have to leave the first and the last tabular column reading is, see here, phi index, phi represents what? It represents the losses. Okay, so what is the losses? Either it is infiltration or percolation or evaporation. Yes, right? So this, once the 1.4 centimeter of rainfall falls onto the ground, so that will completely infiltrated into the ground surface, means it won't be available. So it will lost as a losses like through infiltration, evaporation. So we should not consider these two. So that's why here, so when you apply other data, so you'll get runoff 3.4 is equal to 3.4 minus 5 plus 4.8 minus 5 plus 3.2 minus 5 plus 2 minus 5. So we have left with the first reading and the last reading we are left, because it is equal to 1.4 and less than 1.4, but you have to consider only the values which are greater than 1.4. So into T is 30 minutes, so divided by 60 because we are converting into hours. So it will be, so if you simplify this, you will get 3.4 is equal to 13.4 minus 4.5 into 30 divided by 60. Okay. So if you simplify this, we'll send this 60 to the left hand side. So 3.4 into 60 is equal to 13.4 minus 4.5 into 30. And so you'll get 204 is equal to 402 minus 125. So if you simplify this, you'll get phi value, that is the phi index, 1.65 centimeter per hour. So here I'll tell you, see here, what is the answer we got? We got it as 1.65 centimeter per hour. So if you see, the initial phi index value should be more than 1.4. So this value is more than 1.4. Yes, right? So whatever the answer you got, this is the correct answer by chance, by any chance. So if you got this instead of 1.65, so you got it as 1.35, which is less than 1.4. Okay, so that is a wrong answer. Okay, so sometimes this initial value that not more than 1.4, they won't mention it. At that time, you have to assume the initial value and you have to check whether it is greater than that particular value. So at that case, you will arrive this condition. When the initial condition, when this particular condition is not given in the problem, then you're going to arrive this condition, like you may get an answer less than the assumed value. So then what you have to do, you have to increase the assumption value. Okay, so you have to revise the new value. So that is how the phi index is calculated. So as I told, so it is greater than 1.4. So the whatever the value which we have obtained, it is a correct value. So that is the calculation of phi index. The next parameter what you have to calculate in this problem is W index. Okay. So how to calculate W index? So W index is equal to P minus Q minus F divided by T. So okay, so that is a formula which is used to calculate the W index. So where P represents the total precipitation, that is with respect to T, and so total precipitation, they have given the rainfall values. Okay, so you have to add all the rainfall values, and with respect to T, so that is 30 minutes interval. So and we have converted into because they have given the this is the total precipitation, that is the depth of precipitation. Okay, so we are converting that into they have given the rate I, the intensity they have given. So this P represents the depth, which is either in terms of centimeter or mm. So what we have, that's why we have multiplied it by time to convert into depth. So 1.4 plus add all the rainfall values which is given into time, that is interval is 30 into 30 divided by 60, you will get 8 centimeter. And similarly, the runoff is 3.4 centimeter they have given, and since the storage they have not mentioned, it is taken to be 0. And T is a 3-hour interval. So T represents the storm duration, it is a 3 hour. So it will be 8 minus 3.4 divided by 3, so which is 1.53 centimeter per hour is the W index value. So this is how we are going to calculate the phi index and W index, which is based on the infiltration problem. So let us see one more problem. So the next problem I'll read out here. A reservoir had an average surface area of 20 kilometers square during June. In that particular month, the mean rate of inflow is 10 meter cube per second. Mean outflow is 15 meter cube per second. Monthly rainfall 10 centimeter, and the change in storage 16 million meter cube. Assume the seepage losses to be 1.8 centimeter. Estimate the evaporation in the month. Okay, so this was also asked on Jan Feb 2021 for 10 marks. So let us write down the given data. So the area they have given 20 kilometer square. Inflow they have given as 10 meter cube per second. Outflow they have given as 15 meter cube per second. Monthly rainfall they have given as 10 centimeter. Change in storage 16 million meter cube. Seepage losses 1.8 centimeter. So and you have to calculate the evaporation. See in this, as they have given inflow outflow, we are going to use the water budget equation. So I hope you remember the water budget equation. Water budget equation is the change in storage is equal to inflow minus outflow. So here delta S is equal to summation of inflow minus summation of outflow. Okay, so they have given a mean inflow and mean outflow. So we have to calculate the total inflow, okay, and total outflow. So the total inflow in centimeter is, see inflow, how many inflows here? See, they have given the mean inflow and rainfall is given. So rainfall will also be the one of the inflow. Yes, right. And similarly, the outflow is given. Okay, the one more outflow is what? It is a seepage loss. Okay, so we have to calculate the total outflow. So total inflow. So total inflow is, that is in centimeter, is summation of inflow is equal to, so 10 into 30 into 24 into 60 into 60, that is nothing but, see here, this whatever this mean inflow, that is 10 meter cube per second they have given. So we are converting that into in terms of depth. Okay, so that's why we have multiplied by 30 into 24 into 60 into 60. And why this 30? Because it is a month of June. Okay, for a 1 month. So 1 month is 30 days. So that's why we have multiplied it by 30. So 10 into 30, and to convert that, to eliminate that second, we have multiplied by 24 into 60 into 60. And so to convert the depth, what we have to do, we have to divide it by area. Okay, so it is 20 into 10 per 6. So into 100, that is because if you see here, so rainfall is in depth. If you see the monthly rainfall which is given, it is in terms of depth, that is 10 centimeter. So what we are doing is we are converting this mean inflow also to be in terms of centimeter. Okay, so here if you see, so that's why we have divided it by area and we have converted that, we have eliminated that second, and we have multiplied it by the number of days, that is 30. Okay, and also we have to convert it from meter to centimeter, we have multiplied it by 100. So plus the another inflow, that is 30 centimeter. So the total inflow will be, so 139.6 centimeter. Okay, so similarly the total outflow, so we have to convert it into centimeter. The total outflow is equal to what? So the outflow they have given as 15 meter cube per second. So it will be 15 into 30 into 24 into 60 into 60 and divided by area, that is 20 into 10 per 6. So into 100, because to convert into centimeter, plus 1.8 and plus evaporation. See here we have to calculate the evaporation. The total outflows are, one is the mean outflow which is given, plus the evaporation plus seepage losses. So total you will get it as 196.2 plus E in terms of centimeter. Okay, and also storage they have already given. So if you see the question, so storage they have given in terms of million meter cube. Okay, so let us just convert that storage to the centimeter. So for that, so here if you see the total outflow is more than the total inflow. So you can notice here, see that is 139.6 centimeter, but this outflow is 196.2 plus E. Okay, means it will again add up. So inflow is lesser, outflow is greater. Okay, so the outflow is more than the inflow. So obviously there will be a depression in storage. Okay, means so outflow itself, the losses are high, but inflow is very less. So at that case, what happens? So the depression in storage will occur. Means the deficiency in storage will occur. So that's why. So you have to consider the negative sign here. So we are converting the storage to centimeter. While converting, you have to consider the negative sign, because here the outflow is greater than the inflow, so which create depression in storage. So that's why this negative sign is considered. So minus 16 into 10 power 6 divided by, so 30 into 10 power 6. Okay. So sorry, it is 20 into 10 power 6 into 100, that is to convert into centimeter. So it will be minus 80 centimeter. So now we have converted change in storage, outflow, inflow, everything in centimeter, that is in terms of depth. So let us just apply to the water budget equation, that is summation of inflow minus outflow is equal to change in storage. So inflow is 139.6 minus outflow is 196.2 plus E, and change in storage is minus 80. So you just calculate, so you'll get, we'll send all these terms to the right hand side. You'll get minus E is equal to minus 80 minus 139.6 plus 196.2. So where E you will get it as 23.4 centimeter. So the evaporation in the month of June is E is equal to, so 23.4 centimeter. So this is the depth of evaporation what we have calculated in the month of June, okay, using the water budget equation. Thank you all. We'll just continue in the next class. We'll see the next topic in the next